Good morning to everyone.
Good morning, sir.
Good morning, sir.
Morning. I think the last class I gave the formula for uh, radius of curvature in parametric form. I think I solved one problem in parametric form. So we will solve at least two more problems, and then we will go to polar form. The next problem is, and also I gave some problems to you. I think some of your classmates done the problem. I think I don't know the name exactly. I think yesterday Somnath. Is it correct? Somnatha. Somnath is here.
Yes, sir.
Okay. I think he solved the
Yes,
two.
sir.
Yeah. Okay. He solved two problems. And Yashashwini, I think today morning, she said, I don't know.
Yes, sir.
Okay, I don't know. I'm not checking your results. Okay, but anyway, I will solve at least two problems now in parametric form. Problem number one. Find the radius of curvature for the following curve at the points. Okay. Find rho. Find rho for the curve is equal to a log of tan pi by 4 plus theta by 2, and the y equal to a secant theta. A secant theta at a general point at theta. We need to find the rho for this curve at theta. Now we should find x dash or x dot. X dot equal to a log. If you differentiate log x, you'll get 1 by x. That is a tan pi by 4 plus theta by 2. If you differentiate tan theta, you'll get secant square theta. Secant square pi by 4 plus theta by 2. And if you differentiate pi by 4 plus theta by 2, you'll get 1 by 2. So this is equal to a 1 by 2, a by 2, a by 2. And then here, this you can write as sine pi by 4 plus theta by 2 divided by cos pi by 4 plus theta by 2. So cos pi by 4 theta by 2 comes to the numerator. Cos pi by 4 plus theta by 2 is coming to numerator divided by sine pi by 4 plus theta by 2. And you can write secant square pi by 4 plus theta by 2 is 1 by cos square pi by 4 plus theta by 2. So if you simplify, you'll get the numerator we have a. The denominator, if you cancel this, you have 2 sine a cos b form. 2 sine a cos b. 2 sine of pi by 4 plus theta by 2 cos of pi by 4 plus theta. Now, this is equal to a by 2 sine A cos B, you can write what?
Sine 2A, sir.
Sine of A plus 2 sine cos B. Okay. So sine of A plus B. Sine of A plus B. That is pi by 4 plus theta by 2 plus pi by 4 plus theta by 2. So we'll get A by sine pi by 2 pi by 2 plus theta is equal to A by sine pi by 2 plus theta is equal to A by cos theta. And you can write this is A, 1 by cos theta is secant theta. This is your x dot. Now x double dot. X double dot equal to, differentiate again with respect to theta, get A into secant theta into tan theta. So what is the second curve? Y equal to secant A secant theta. Y equal to A secant theta. Find y dot and y double dot. Y dot equal to A into secant theta into tan theta. And the y double dot is equal to, so UV method, so A into, if you keep secant theta, to differentiate tan theta, you'll get this secant square theta. So secant cube theta. And if you differentiate secant theta, you have secant theta into tan theta. So A secant theta to tan square theta. I find everything. The remaining thing you should substitute in the formula. So x dot, x double dot, y dot, and y double dot. So formula is rho equal to x dot square plus y dot square whole power 3 by 2 divided by x dot into y double dot minus x double dot into y dot. So I'm going to find the numerator separately and denominator separately. So first numerator, x dot square plus y dot square whole power p by 2. So we know that x dot is a secant theta. So a secant a square secant square theta plus y dot. Y dot is a secant theta into tan theta. So a square secant square theta into tan square theta whole power 3 by 2. So take commonly a square secant square theta. So 1 plus tan square theta whole power 3 by 2. So this is equal to a square whole power 3 by 2 is a cube. Secant square theta whole power 3 by 2 is secant cube theta. This is secant square theta. One is secant square theta. Okay, secant square theta whole power 3 by 2 is secant cube theta. So you get AQ into secant power 60. Now the denominator is equal to x dot into y double dot minus x double dot into y dot is equal to x dot is a secant theta. Anybody got the answer?
So A secant square theta.
A secant square theta is correct. So A secant theta into y double dot. What is y double dot? Double dot is A secant cube theta. A secant cube theta. Please check your answer also. A secant cube theta plus A secant theta into tan square theta. Then minus x double dot. X double dot is A secant theta into tan theta. A secant theta into tan theta is x double dot, and then y dot is
A sec theta tan theta.
okay. Thank you. A secant theta into tan theta. So now, if you simplify this, you can write this is a square secant power 4 theta secant power 4 theta plus a square secant square theta into tan square theta, and then minus a square secant square tan square theta. So I think you can cancel these two. So you get the denominator is a square into secant power 4 theta. So the numerator is a cube secant power 6 theta. So I will write here rho equal to numerator divided by denominator. Numerator is a cube to secant power 6 theta divided by a square into secant power 4 theta. The final answer is a into secant square theta. A into secant square theta. Second problem. Find rho for the curve x is equal to a into theta minus sin theta and y equal to a into 1 minus cos theta. Actually, this equation is called cycloid. There are, I think, 3 or 4 types of cycloid. I don't know exactly the number of cycloids, either 3 or 4. Please check in the net, okay, how many cycloids are available, and find out those equations. Okay, maybe that is useful for your engineering drawing. Okay, so this is one of the cycloid equation. Already I gave the equation of catenary. Catenary, I think this is the equation of catenary. Y equal to C into cos h x by c. So you should know the name also. This is a equation of catenary. This curve looks like a hanging chain. Okay. Okay. Now I leave this part to you. Please check in the net. So how cycloids looks like, how many cycloids are there, how catenary looks like. Okay. Now the problem is now okay. Find rho. Find rho for the cycloid at the general point. I think formula solve this problem, but using the formula, this formula, which formula, x dot y dot formula. Okay, but I am going to solve the same problem by using direct formula. Direct formula means Cartesian coordinates. That is rho equal to 1 plus dy by dx whole square whole power 3 by 2 divided by y dash. So first dx by d theta, dx by d theta equal to a into differentiate with respect to theta 1 minus cos theta, then dy by d theta, a into if you differentiate cos theta, you'll get what? Minus sin theta, so minus of minus plus, so a sin theta. A sin theta. And then I need dy by dx. So that's why this is dy by d theta by dx by d theta. So a sin theta divided by a into 1 minus cos theta. So a gets cancelled. You have sin theta divided by 1 minus cos theta. So you know the formula for sin 2 theta, that is 2 sin theta into cos theta. So from this sin theta is 2 sin theta by 2 into cos theta by 2. So similarly for 1 minus cos 2 theta equal to 2 sin square theta. So 1 minus cos theta equal to 2 sin square theta by 2. Sin square theta by 2. So after cancelling 2 and 2 and 1 sin theta by 2, you'll get cos theta by 2 divided by sin theta by 2. That is cot theta by 2. So first derivative dy by dx or y dash is equal to cot theta by 2. Next, I am going to find the second derivative, d square y by dx square. Which is equal to, you can write this is d by dx of dy by dx. And this is equal to, using chain rule, you can write d by d theta, and dy by dx is cot theta by 2. Dy by dx is cot theta by 2, and then differentiate theta with respect to x. So if you differentiate cot theta by 2, you will get minus secant square theta by 2. to 1 by 2 d theta by dx. But we know that dx by d theta, we know that dx by d theta by dx is the reciprocal of this. That is 1 by a into 1 minus cos theta. 1 by a into 1 minus cos theta. So this is equal to 1 by 2 minus 1 by 2 to a to a. You can write cosecant square theta in terms of sin theta. So 1 by sin square theta by 2. And 1 minus cos theta, again that is 2 sin square theta by 2. So second derivative is minus 1 by 4a into 1 by sin power 4 theta. This is the second derivative. Now rho equal to 1 plus, I'm writing directly, plus y dash square. Y dash is cot theta by 2. So cot square theta by 2 whole power 3 by 2 divided by second derivative minus 1 divided by 4a into sine, the denominator will have sine power 4, which is equal to 1 plus cot square theta by 2 is cosecant square theta by 2. Cosecant square theta by 2 whole power 3 by 2 into, so rho is always positive. So this is 1 by 4a into sine power 4 theta by 2. It's a reciprocal. Is what? 4a into sine power 4 theta by 2 sine power 4 theta by 2. Okay, now if we simplify, so 2 gets cancelled. This is sine cube theta by 2. Cosecant cube theta by 2. Cosecant cube theta by 2, you can write 1 by sine cube theta by 2 into 4a to sine power 4 theta by 2. The final answer is 4a into sine theta. I think know how to solve problems in parametric form. You can either use this formula directly, or otherwise you can use the formula for parametric form. So that is up to you. So you should decide which one is easier for. And then third problem. So this is the last problem in parametric form. Now I am going to solve. Next I am going to polar form. Third problem, find rho for the curve x is equal to dA into cos theta minus a into cos 3 theta, and y equal to dA into sin theta minus a into sin 3 theta. So dx by d theta is equal to, if you differentiate with respect to theta, I'll get minus 3a sin theta differentiate cos 3 theta, you'll get minus sin 3 theta into 3. So minus into minus plus 3a sin 3 theta. So take 3a commonly, you'll get sin 3 theta minus sin theta. This is dx by dt. Similarly, find dy by dt. Dy by d theta. You get 3a cos theta, 3a cos theta minus 3a sin 3a. Differentiate this one, you get 3a cos 3 theta. So if you take 3a commonly, have cos theta minus cos 3 theta. Now dy by dx equal to dy by d theta divided by x by d theta. So dy by d theta is 3a into cos theta minus cos 3 theta divided by dx by d theta is 3a into sin 3 theta minus sin theta. The numerator, you should use the formula cos c minus cos d formula. For the denominator, you should use the formula sin c minus sin d formula. So 3a gets cancelled. 3a gets cancelled. So this is equal to, you can cos c minus cos d is minus 2 times sin of c plus d by 2. Sin of c plus d by 2. That is 4 theta divided by 2. That is 2 theta. Otherwise, I'll write theta plus 3 theta by 2. And into sine of c minus d. C is theta minus 3 theta by 2. All divided by sin c minus sin d is 2 cos of c plus d. 3 theta plus theta divided by 2 to sin c minus d by 2. 3 theta minus theta by 2. So if you simplify, the next step I will write 2 gets cancelled. We'll get minus this sine 2 theta sine 2 theta, and this is sine of uh, minus theta. Sine of minus theta is sine minus sine theta. Okay, I'll write next step. Sine of minus theta all divided by 2 cos 2 theta. Sorry, 2 gets cancelled. So cos 2 theta to sine theta. Cos 2 theta into sine theta. Now dy by dx is equal to sine of minus x is minus sine x, so minus into minus plus. So sine 2 theta into sine theta divided by cos 2 theta into sine theta gets cancelled. You get tan 2 theta. So this is the first derivative. The second derivative, anybody got the second derivative? Anybody got the second derivative?
2 secant square 2 theta into d theta by dx.
You are telling the final answer or
Second derivative.
second derivative? 2 secant square 2 theta divided by.
Into d theta by dx.
Okay, we'll check it. Please write. D by dx of dy by dx. You can write this is dy d theta of dy by dx is tan 2 theta to d theta by dx. If you differentiate tan 2 theta with respect to theta, you'll get secant square 2 theta into 2 and d theta by dx. So we know that dx by d theta. What is dx by d theta? 3a sine theta minus sine theta. So the reciprocal of this is 1 by 3a into sine 3 theta minus sine theta. So 1 by 3a into sine 3 theta minus sine theta. This is equal to 2 secant square 2 theta. Again, you should use sine c minus sine d formula. 3a. This is already you used this formula already, so I'm writing directly. So 2 cos c plus d by 2, that is 4 theta by 2 is 2 theta minus 2 sine of c minus d by 2 sine of c 3 theta minus 2 theta by 2 is theta. Okay, now so you can cancel what? You can cancel sine. Okay, you can write this is 1 by cos 2 theta is secant 2 theta. So 2 gets cancelled. 2 gets cancelled. Secant cube 2 theta, cube 2 theta divided by 3a into sine theta. 3a into sine theta. So otherwise, if you want to write in terms of cos, you can write. Okay, that is up to you. This is the second derivative. Now substitute everything in the formula. Rho equal to 1 plus first derivative is what? Tan 2 theta. So tan square 2 theta whole power 3 by 2. So what is the second derivative? Second derivative is secant cube 2 theta divided by, so that's why I'll write the numerator, 3a sine theta. So this is secant square 2 theta whole power 3 by 2. So you'll get secant cube 2 theta. I'm written directly divided by secant cube 2 theta to 3a sine theta. So these two gets cancelled. The final answer is 3a sine theta. Okay. So now, so here I solved some more problems in parametric form. So please just, I'm not going to explain this. So I'll give to you. You'll just go through. If you have any doubts, you can ask in the next class or through WhatsApp. You can ask. Here, I just meant read the problem. Find the radius of curvature of the asteroid. Find the radius of curvature of the asteroid. You should write. You should know the parametric form as usual. X dot, x double dot, y dot, y double dot, its numerator. This is the numerator value. This is the denominator value. The numerator divided by denominator, you will get the final answer. Okay. One second problem. Find rho for the curve at the general point. So the same method, find dx by dt. And here I am using direct formula, dx by dt, and then dy by dt, and dy by dx is equal to dy by dt divided by dx by dt. I got tan t. And second derivative, so you know how to find the second derivative. So please go through. So the final answer rho equal to kt. So I think I gave this problem as a practice problem. Is it correct or not? Whether I gave this problem? Okay, I think some of you solved. I don't know the name because 2 days before, 2-3 students are solved this problem and sent to me. Okay, but I want to discuss this problem because this problem is a little bit different from the ordinary problems. So similar type of problems I want to focus more. Okay, I don't want to focus the routine problems. Okay, find rho at dt comma c by t on the curve xy equal to c square. That is the hyperbola. And prove that rho equal to r cube by 2c square, where r is the distance of any point x comma y on the curve from the origin. From the origin. So you should know what is r. R is the distance of any point x comma y on the curve from the origin. Hence deduce that rho at c comma c. Okay. So there are 3 parts. First, okay, you can split into 2 parts. So first you need to prove that a rho equal to r cube by 2c square, and then you need to find rho at c comma c. X is equal to ct. To find x dot means dx by dt. Dx by dt is c. X double dot 0. Y equal to c by t. Y dot, if you differentiate with respect to t, you get minus c by t square. And then y double dot, if you differentiate again, you get 2c by 2t cube. Okay. So next, this is a formula, you know that. So x dot is c. So x dot square is c square. Y dot is minus c by t square. So y dot square whole power 3 by 2 divided by x dot is c, y double dot is 2c by t cube, and we know that x double dot is 0, so that's why here 0. So c square plus c square by t power 4 whole power 3 by 2. Denominator we have 2c square. This t cube is coming in the numerator. So take LCM here. So c square t power 4 plus c square, okay, divided by t power 4 whole power 3 by 2. So this t, after taking LCM t power 4, I am writing here t power 4 whole power 3 by 2 here to t cube divided by 2c square. Okay. Now from here I am taking c square commonly. If you take c square commonly, you should write c square whole power 3 by 2. So 2 gets cancelled. Remaining you have t power 4 plus 1 whole power 3 by 2. The denominator we have, if you cancel this 2 and this 4, you will get 2. So 2 into 3, 6. So t power 6 into t cube divided by 2c square. Next you can cancel t cube and t power 6, you will get t cube. Okay. T cube. Okay. So t cube, but here have c square. Okay. Check it. So c cube, rho equal to c cube into 1 plus t power 4, 1 plus t power 4 whole power 3 by 2 divided by 2 c square t cube. 2c square t cube. Okay. So even you can cancel this c square, but I kept here. Maybe I will use later. I think I told that this is up to this is the first part. Okay, finding row, find the row. Okay, in terms of t, in terms of t. But the question they are asking in terms of r, in terms of r. The first part is find row in terms of t, that is finished. Next, we need to find a row in terms of r, where r is the distance of any point x comma y and the hyperbola from the origin 0 comma 0. That is the second part. So r is any point x and the hyperbola from the origin. So distance between the 2 points using the formula. So x minus 0 whole square plus y minus 0 whole square equal to r square. So r is the distance. So the general point on the hyperbola is ct and c by t. Instead of x, I am substituting ct, and instead of y, I am substituting c by t. It simplifies c square t square plus c square by t square equal to r square. So take c square commonly, t square plus 1 by t square equal to r square. So r square equal to, if you take t square LCM, c square into t power 4 plus 1 by t square. Actually, this is c square. But I need r. I need r. So that's why I'm going to take whole power. I need r cube. I need r cube. That's why I'm going to take whole power 3 by 2 on both sides. 3 by 2 on both sides. Take 3 by 2 on both sides. We get r square whole power 3 by 2. R square whole power 3 by 2. I'll write here. R square whole power 3 by 2 equal to c square whole power 3 by 2 into 1 plus t power 4, 1 plus t power 4 divided by t square whole power 3 by 2. So 2 gets cancelled, 2 gets cancelled. So r cube equal to c cube into 1 plus t power 4 by t square whole power 3 by 2. Check it here. So c cube into 1 plus t power 4 3 by 2 divided by t cube. Okay, now I think the same thing is here. There is nothing new from here to here. But we know that rho is c cube into 1 plus t power 4 into 3 by 2 divided by t cube into 1 by c square. You can check it, the previous. This is our rho. So I am writing 1 by 2c square separately. Yeah, because we know that c cube into 1 plus t power 4 3 by 2 by t cube is r cube. So instead of this expression, I will replace by r cube to 1 by c square. So rho equal to r cube divided by 2c square. So second part is also over. The third part, we need to find a row at c comma c. So we find row at ct comma c by t. So that is this expression. That is equation number 1. This equation number 1 is row at ct comma c by t. So first, this is coming from equation 1. Okay, now if you substitute t equal to 1 here in ct comma c by t, I'll get c comma c. Similarly, you should substitute t equal to 1 here. So rho at t equal to 1 is c into 1 plus 1 whole power 3 by 2 divided by 2. So 2 root 2 into c by 2. So 2 gets cancelled. So final answer is c root 2. Okay. So next, I think still have 15 minutes or more time. Now I'm going to introduce the formula for radius of curvature in polar form. Okay. Formula is rho equal to r square plus r dash square whole power 3 by 2 divided by r square minus r into r double dash plus 2r dash square. So you should remember this formula. So again, this formula is coming from the first formula, but the proof is a little bit lengthy, so that's why I avoid the proof here. So where r dash is equal to dr by d theta and r double dash is d square r by d theta square. Okay, so now I will solve the one or two problems and then I will show some other problems later. Okay, but if you initially if I show that, so you may not understand the concept, because that's why I will choose some other problems. Okay, then first I will solve at least two problems and then the remaining problems I will show to you. First I will write the formula. So radius of curvature in Cartesian form. Formula is rho equal to r square plus r dash square whole power 3 by 2 divided by r square minus r into r double dash plus 2r dash square, where r dash is dr by d theta and r double dash is d square r by d theta square. First problem, find rho find the radius of curvature. Okay, find the radius of curvature at any point on the equiangular spiral. Equiangular spiral. So again, I think you know the equiangular spiral. Okay, it is coming like this. Okay, if you see in the, for example, forecast, if you the storm, it will and okay, it will come like this. Okay, so it's look like this. Okay, equiangular spiral. Okay, so I am not drawing properly. So again, please check how equiangular spiral looks like. Find the rho for the equiangular spiral. R equal to A into e power theta into cot alpha. Okay. So solution. Again, you need to find first R dash. R dash. R dash is equal to, differentiate with respect to R dash means dr by d theta. So A into e power theta. Okay, if you differentiate e power theta, you get e power theta to cot alpha. If you differentiate theta into cot alpha, you'll get cot alpha. Cos alpha, cot alpha. So, and we know that this is again R. So this is R into cot alpha. R dash is equal to R into cot alpha. Similarly, R double dash. R double dash. So if you differentiate again this one, okay, so A into cot alpha is constant, okay, this is a constant. If you differentiate again e power theta into cot alpha, power theta cot alpha, again cot alpha, so cot square alpha. Yeah, please tell.
Sir, for e power theta into cot alpha, shouldn't we take UV rule for theta into cot alpha?
Sorry, I can't understand properly. Please tell.
Okay, for e power theta into cot alpha,
Hmm.
for the theta into cot alpha part, shouldn't we take UV rule, sir?
No, no,
For
no,
the
no.
difference.
No, no. Actually, here cot alpha is a constant. Alpha is a constant here. This is r
Oh,
comma. Okay, so r comma theta. Okay, cot. It is cot theta. Then u will become. Okay, this is just
okay,
cot
sir.
alpha. Okay, thank you. So this if you differentiate again e power theta into cot alpha, e power theta into cot alpha. Again we get cot alpha. So cot alpha into cot alpha, cot square alpha, and this is nothing but r. So r into cot square alpha. Okay. Now I'll go to the formula. Rho equal to r square. R square is I'll write directly a square to e power 2 theta into cot alpha. This is a square. R square. So r dash square. So this is r dash square. Okay. Otherwise, you can do like this. You can do it a little bit simpler form. So you keep r square as it is. Otherwise, little bit big. Go a little bit bigger. So r square, I'm keeping as it is. R dash square is what? R square cot square alpha. R square cot square alpha whole power 3 by 2 power 3 by 2 divided by r square. We'll keep r square as it is minus r into r double dash. Multiply this one by r. So multiply this one by r. So minus r square into cot square alpha and plus 2 into r dash square. R dash square is r square cot square alpha. Now if you simplify, to take r square commonly, r square whole power 3 by 2 is r cube to 1 plus cot square alpha, that is cosecant square alpha cosecant square alpha whole power 3 by 2. Denominator will have r square. If you add these two, you get r square alpha. So this is equal to r cube, 2 gets cancelled, cos cube cosecant cube alpha, cosecant cube alpha by you take r square commonly. Take r square commonly. 1 plus cot square alpha is cosecant square alpha. After cancelling r and cosecant alpha, finally you'll get r into cosecant alpha. This is the final answer. I think still we have only 5 minutes. Just I will explain only one problem here. Find rho for the curve r equal to a into 1 plus cos theta at the point theta equal to pi by 2. Curve is given. Find the rho at theta equal to pi by 2. So point is also given. So r equal to a into 1 plus cos theta. So find r at theta equal to pi by 2. So if you substitute theta equal to pi by 2, cos pi by 2 is 0. So you'll get a. Similarly, r dash. R dash means you get minus a sin theta. R dash at theta equal to pi by 2 is sin pi by 2 is 1. So r dash is equal to minus a at theta equal to pi by 2. R double dash equal to minus a into differentiate sin theta, will get cos theta. R double dash at theta equal to pi by 2 is 0. Cos pi by 2 is 0. So I got the value of r dash, r double dash at theta equal to pi by 2. So now substitute in the formula. So this is the formula, r square plus r dash square whole power 3 by 2 divided by r square minus r into r double dash plus 2r dash square. Okay, and what is r? R is a, so r square is a square. R dash is minus a whole square whole power 3 by 2. R square again a square, and then which one is 0? R double dash is 0. You can check it. R double dash is 0. So the second term is 0 in the denominator, plus 2 r dash is a, r dash square is 2a square. So a square plus a square, 2a square whole power 3 by 2 divided by 2a square plus a square is 3a square. So 2 power 3 by 2 is 2 root 2. A square whole power 3 by 2 is a cube divided by 3a square. The final answer is 2 root 2 divided by 3 is 3 into a. So this is the final answer. Okay, now I will give some other problems, practice problem in radius of curvature in polar form. So you can try to solve that problem. The first problem is from the book. Okay, even you can try the example. This is an example. Find the rho at the point, general point, r comma theta on the curve, r square into cos 2 theta equal to a square. This is the first problem. Okay, please note down. R square into cos 2 theta equal to a square. The second problem is the first problem, the answer is r equal to rho equal to r cube by a square. So note down the answer also. Second problem, show that the points of intersection of curves r equal to a theta and r equal to a by theta, comma, their curvatures are in the ratio 3:1. Or in the ratio 3:1. This is also an example problem. So don't see your book. So try individually. If you have a doubt, and then you can look at your book. So this is a little bit different problem. Okay. So the idea is you should find the radius of curvature for each of the curve. That is rho 1 and rho 2. So here I calculated rho 1. Next I calculated for second curve everything again r dash, r double dash, and then rho 2. And then before that it is given. I show that the point of intersection of the curve. So we need to find the point of intersection of the curve. So r equal to a theta, r equal to a by theta. So From this, we know that a theta equal to a by theta because the left hand side is same. Then you can equate the right hand side. So a theta equal to a by theta. So a gets cancelled. Theta square equal to 1. So theta equal to plus or minus 1. So this is the intersection point. Should find rho 1 at theta equal to plus or minus 1. Similarly, rho 2 at theta equal to plus or minus 1. So I got rho 1 and rho 2. And then that is 1 by 3 is to 1. The reciprocal is the curvature, that is 3 is to 1. So this is the idea. We'll try these two columns. Again, we will discuss Monday. Monday, I think 4th hour. So if you have any doubts, you can ask me. Today, one of the students asked a question. The question is still I don't find the answer, but still I'm trying. If I get the answer, I will tell in the classroom. But the only thing I got the problem like this. Okay, but I can't find the solution. I want to tell that problem now. If you have the next hour class, okay, I don't know whether this problem is correct or not, first of all, but I got dy by dx is equal to 0 by 0. Q plus y cube equal to y minus x into y minus 2x. So at 0, 0. This is the curve. So you should use the Cartesian form. So I got dy by dx is equal to, I'll tell the expression also. Please write. What is the next hour? Priya?
Yes, sir.
சொல்லிருப்பீங்க.
Sir, I got dy by dx as 4x minus.
This problem,
Yes, sir.
4x
minus 3.
4x minus. Okay, yeah, I found out. Y dash is equal to 4x minus 3y. I got this. Please check it. Minus 3x square by 3y square minus 2y plus 3x. So if you substitute 0, 0, you'll get 0 by 0. But I don't know how to proceed further. But the answer in the book, it is given 5 root 5 by 80. So still I'm thinking about this. So please think you also. Okay, if you got the answer, very nice problem, because even I don't think about like this. Okay? So in this direction. Okay, thank you. We'll meet again on Monday. 4th.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you so much.
Thank you, sir.
Thank you.